Now, how to show the atom of an element with the atomic number and the mass number? So, this is the way to represent an atom with the atomic number and the mass number. Please remember, the mass number is always written on top and atomic number is written at the bottom. Mass number as a superscript at top and atomic number as a subscript, means at the bottom. So here you can write, for example, for sodium atom can be written Na as a symbol and mass number is 23 written on top and atomic number is 11 written at the bottom. Similarly, for oxygen atom can be shown with the mass number 16 on top and atomic number 8 at the bottom. Similarly, if I want to write magnesium atom with the atomic number 12 at bottom and mass number is 24. So 24 will be the superscript and 12 the subscript. Okay children, this is the way to write the atomic number and mass number of an atom. Okay, now there's a problem over here. An atom has 4 protons, 4 electrons and 5 neutrons. What is the atomic number and the mass number? See, what is atomic number? It is number of the protons. So, how many protons are there? There are 4 protons. So, atomic number will be 4. Okay? Atomic number will be 4. And what is the mass number? Mass number is the sum of number of protons plus number of the neutrons. So, mass number is protons plus neutrons is equal to protons how many? 4 plus 5. That is 9 mass number. 9 is the mass number for this atom. Okay children? Let's solve few questions based on atomic number and mass number. The question is, how many protons, electrons and neutrons are present in the following atoms? You need to find out the number of the protons, number of electrons and number of the neutrons in the following atoms. Also, indicate the atomic number and the mass number. You need to tell which is the atomic number and which is the mass number. Okay children, so first is oxygen, 16 and 8. 16 is superscript and 8 is subscript. So atomic number is the down part, that is 8. So atomic number is 8. Okay, mass number is the superscript, that is 16. Okay, number of the protons, so atomic number is equal to the number of the protons, which is equal to number of the electrons in this neutral atom. So number of the protons will be equal to atomic number, that is 8, and number of electrons also will be 8. Now number of the neutrons. See, number of the neutrons, as we know, the mass number is 16, which is the sum of number of the protons plus number of the neutrons, right? Atomic number is equal to number of the protons. It is just equal to the, which is equal to the number of the protons. Okay. And mass number equals to protons plus neutrons, right? So number of the neutrons equals to mass number minus the atomic number. So it will be 16 minus 8, that will be 8. So number of neutrons will also come 8. Okay children? So number of neutrons is equal to mass number minus the number of the protons, because mass number is sum of protons and neutrons. If you subtract the number of the protons from it, what you are going to get? You are going to get the neutrons. Okay. Now the second is potassium, 1938. Atomic number will be the subscript. So atomic number is 19, mass number is the superscript, that is 38. So number of the protons, I know atomic number equals to number of protons. So it will be 19. Number of protons equals to number of the electrons in the neutral atom. So Number of protons equals to 19, number of electrons also equal to 19. Now number of the neutrons, I told you it is mass number minus the atomic number. So mass number is 38 minus 19. Okay, so how much you will get? 9 and here 19. This is the number of the neutrons present in the potassium atom. Okay children? Here is some extra information for you all. In an atom, there are 200 subatomic particles. The protons, neutrons, electrons just make up 3 of the total 200 subatomic particles. In the nucleus, we have the protons and the neutrons. Protons and neutrons are further made up of even more smaller particles known as quarks. And these quarks are held together by the other elementary particles known as gluons. So gluons act as a glue to stick the quarks together. Let us study the element and the compound. Children, pure substances are divided into elements and compounds. The pure substance, which is in the simplest form and cannot be further divided into simpler substances, they are known as an element. Okay, so elements contain the same kind of atoms. Oxygen gas will be having only the oxygen atom. Nitrogen gas will be having only the nitrogen atoms. Metals like sodium will be made up of sodium atoms only. Magnesium will be made up of magnesium atom only. Chlorine gas made up of chlorine atoms only. So these are the examples of elements. Now let's study about compounds. Compound is also a pure substance, but it is made up of 2 or more elements. Means 2 or more different kind of atoms which are chemically combined in a fixed ratio by weight. Okay, over here there are 2 or more kind of atoms which are involved. In element there was only one kind of atoms, right? Same kind of atoms were there. But in compounds you have 2 or more elements, means 2 or more atoms will be there which are combined chemically in one particular ratio or in fixed ratio by weight. Okay, and these compounds can be further broken down into simpler elements by some chemical methods. So for example, water. Now water is written as H2O, right? So H2O, it must be having the atoms of hydrogen also. It must be having the atoms of oxygen also, right? That's why water is a compound having 2 types of the atoms, right? So how many atoms of hydrogen are there in water? 2 hydrogen atoms are there, right? And how many oxygen atoms in water? 1 oxygen atom is there. So mass of 1 hydrogen atom is 1, okay, and mass of 1 oxygen atom is 16. So mass of hydrogen in water will be, there are 2 hydrogen atoms, so it will be 2 into mass of 1 hydrogen atom, so total 2. And over here 1 oxygen atom, mass of 1 oxygen atom is 16, so mass over here of oxygen will be 16 in water, right? So it can be written as 2 into 1 for the hydrogen, 2 atoms of hydrogen into the mass of 1 hydrogen atom, and here 1 oxygen atom is there multiplied with mass of 1 oxygen atom, that is 16. So 2 into 1 is 2 and 1 into 16 is 16. 2 is to 16 is the ratio. Now 2 is to 16 can be simplified further. 2 ones are 2, 2 eights are 16. 1 is to 8 is the fixed ratio of hydrogen is to oxygen in the water molecule. Water contains hydrogen and oxygen in a fixed ratio of 1:8. So this will be fixed. Okay, this can't be changed for making up of the water molecule. The water molecule is like HOH, hydrogen, 2 hydrogen and 1 oxygen. Okay. Students, in this skillful, you need to choose the elements and compounds by looking at their formulas. We know elements, they are made up of the same kinds of atom. Please remember it. And compounds, they are made up of 2 or more different type of the atoms. Okay. So here elements, let's find out the elements. Nitrogen, because nitrogen gas is having only nitrogen atoms, only one kind of atoms. Hydrogen, H2 molecule, and then we have aluminium. Aluminium will be having only aluminium atoms in it. Iron will be having only iron atoms in it. Magnesium will be having only magnesium atoms in it, right? Only one type of atoms in the elements. Let's come to the compounds. Now CO2, carbon dioxide, it will be having carbon atom as well as oxygen atom. So it is a compound. Methane, CH4, it will have carbon atom as well as the hydrogen atom. H2O, water is having hydrogen atoms and oxygen atom. So different type of atoms are there, hence it's a compound. Carbon monoxide, carbon atom as well as oxygen atom, hence it's a compound. And ammonia, NH3, having nitrogen atoms as well as the hydrogen atoms in it, so it is also a compound. Here we will see how the names of the elements were represented by using certain symbols. Like in our daily life, we use short forms or abbreviations or nicknames. In the same way in chemistry, the names of the elements were represented in the shortened forms, which are known as symbols. Now, in ancient time, alchemists used very difficult and complicated symbols for those elements and the compounds, which are shown in the figure. You can see here gold, copper, tin, earth, mercury, water, common salt, silver, iron and sulfur. These were the symbols which were used for these elements and the compounds. An Englishman named as John Dalton invented symbols for the atoms of the elements. He was the first one to give a figural representation for various elements. He used very simple figures to represent the elements, like circles, circle with dots, etc. He put forward atomic theory. This theory is also known as Dalton's atomic theory. The features of Dalton's atomic theory are: the first feature is matter is made up of tiny particles called atoms. Means every element is made up of extremely small particles known as atoms. Second point is atoms are indivisible. Atoms cannot be divided further into simpler substances, or atoms cannot be cut. Third point, atoms cannot be created or destroyed. Means atoms are indestructible. Fourth point, atoms of the same element are identical in mass and other properties also. So, a particular element will be having its own type of atoms which will be same in other properties as well as in mass. For example, nitrogen gas will be having only the nitrogen atoms. Oxygen gas will be having only the oxygen atoms. So same atoms. Atoms of different elements differ in their masses and their properties. For example, magnesium will be having magnesium atom only. Magnesium will not be having the atoms of nitrogen or oxygen in it. So, every element is having its own types of atoms. Students, later on, J.J. Berzelius introduced the modern system of naming elements by their symbols. He suggested few rules for writing the symbols of the elements. The first rule was some elements were named on the basis of their starting letters. For example, hydrogen, the starting letter is H, symbol becomes capital H. For carbon, the symbol becomes capital C. For nitrogen, as first letter is N, its symbol becomes capital N. Oxygen, the first letter is O, so its symbol becomes capital O. For fluorine, it becomes capital F. For phosphorus, as first letter is P, so its symbol becomes capital P. The second rule which he suggested was some elements were named on the basis of their first two letters when the first letter was already chosen. Look here, helium, the first letter H is already selected for hydrogen element. So we have to take the other letter as well, that is E. So first two, He. He goes for the helium element. Next, lithium, the first two, L and I. Lithium symbol is Li. Then we have neon. First letter N is for the nitrogen. So we can't take N for neon. So we'll take first two, N and E. So Ne is for the neon. Aluminium, A and L. First two letters and its symbol becomes Al. Aluminium. Silicon, first two, S and I. The symbol becomes Si for the silicon, because S, first letter S is for the sulfur. Okay, so we'll take the other one also, Si. The third rule was some of the elements were named on the basis of their first letter and the third letter. Okay children, so over here, for example, chlorine. The chlorine symbol will be C and L. Cl. For argon, first two, Ar. So A and R symbol for the argon. Then calcium, first letter C is for the carbon. So we can't take symbol C for calcium. We have to take first two, that is Ca for calcium. Manganese, M and N. Mn for manganese. Nickel, N and I. N and I, because just N if we take, that will show the nitrogen, right? So we have to take first two, Ni for the nickel. Zinc, Z and N. Bromine, Br for the bromine. Krypton, K and R for the krypton, because the first letter K stands for the potassium. Okay. Iodine, first letter only, so symbol becomes I. Barium, first two, Ba. Radon, first two, Ra. Okay children. J.J. Berzelius also suggested that the symbols of certain elements are based on their Latin names. Gold, Latin name is aurum, so its symbol becomes Au, the first two letters. Silver, Latin name argentum, so the symbol becomes Ag. Mercury, hydrogyrum, Latin name, its symbol becomes Hg. Copper, Latin name cuprum, so its symbol becomes Cu, first two letters. Lead, Latin name plumbum, symbol becomes Pb. Iron, Latin name is ferrum, so its symbol becomes Fe, first two letters. Sodium, Latin name natrium, it becomes Na. Potassium, its Latin name is kalium, symbol becomes capital K. Tin, Latin name is tannum, symbol becomes Sn. Antimony, Latin name is stibium, the symbol becomes Sb. Tungsten, Latin name is wolfram, which is a German name, and the symbol becomes capital W. So this is the way to write the symbols of the elements. Students, why are symbols important? Symbols represents name of the element. It tells the atoms of that particular elements. You can write the name of that element by looking at the symbols, and symbols requires less time and space. For example, Na is a symbol. Name of the element is sodium. Atom of the elements, here will be sodium atoms in the sodium element. And you can write the name of the element, sodium we can write, and the symbol required less time and space. Students, we will study about atomicity. What is atomicity? It is the number of atoms in a molecule of an element. Very important. Okay, so it tells us how many atoms are present in one molecule of a particular element. Okay, students, can you define molecule? Atoms, when joined together, they form molecules, and molecules are of two types: homoatomic molecules and heteroatomic molecules. Homoatomic molecules means same kinds of atoms are joined together to form the homoatomic molecules. Heteroatomic molecules, when different kinds of atoms are joined together, they form the heteroatomic molecules. Here we will study about the homoatomic molecules. When same kinds of atoms are joined together, they form the homoatomic molecules. Now, molecules are of two types: monoatomic molecules and polyatomic molecules. Monoatomic molecules means one molecule containing one atom. Polyatomic molecule, one molecule containing more than one similar kind of atom. Okay, so monoatomic example is helium, neon, krypton, argon, etc. All the inert gases are the monoatomic molecules. Means one molecule of helium contains one atom of helium. One molecule of neon contains one atom of neon. One molecule of krypton contains one atom of krypton. One molecule of argon contains one atom of the argon. Here, polyatomic, one molecule contains more than one similar kind of atoms. For example, they are further divided into diatomic molecules, triatomic molecules and tetratomic molecules. Diatomic molecules, one molecule having two same kinds of the atoms. Okay, hydrogen, nitrogen, oxygen, chlorine. So one molecule of the hydrogen contains two atoms of hydrogen. One molecule of nitrogen contains two nitrogen atoms. One molecule of oxygen contains two oxygen atoms. One molecule of chlorine contains two chlorine atoms. Now triatomic molecules. Triatomic molecules means one molecule containing three same kinds of the atoms. Example, ozone. Ozone is written as O3. So one molecule of ozone contains three atoms of oxygen. Okay. Tetraatomic molecules means one molecule contains four same kind of the atoms. For example, phosphorus. Phosphorus is written as P4. It means one molecule of the phosphorus has four phosphorus atoms in it. Okay. Let us quickly recap. Examples for monoatomic molecules: all the inert gases like helium, neon, krypton, argon, etc. Polyatomic molecules are further categorized into diatomic molecules, triatomic molecules and tetraatomic molecules. Diatomic molecules like hydrogen molecule, nitrogen molecule, oxygen molecule, chlorine molecule. Triatomic, ozone molecule, and tetraatomic, phosphorus molecule.